Now let's take a look at properties of the normal distribution. So many physical quantities such as height and mass are distributed symmetrically and unimodally about the mean. So when we talk about symmetrically, we talk about how the left half here is a mirror reflection of the right half here. And when we talk about unimodally, we talk about there being like one hump. That's what we talk about. Okay? So this is known as the bell curve, also known as the normal distribution. So as soon as we see a bell curve, and you can see it just like a little bit below here, we talk about the normal distribution. The normal distribution is very useful since it allows us to calculate probabilities in a wide range of contexts. So let's talk about the normal distributions, okay? So first, we can describe the normal distribution by their mean and their standard deviation. Let's make this skinnier. Okay, so what we do is we put the mean right at its hump because the average is going to be wherever the hump is. So whether the normal distribution is wider or more narrow, as long as it's in a bell curve and it's normal distribution, the average or the mean is right at the peak of the hump. Okay, and that means that this is also the mode. So in a normal distribution, the mode and the mean are actually the same value. Now, as we move away from the mean, what we do is we quote how far away from the mean we are, but in standard deviations. So this would be the average. See right here, the average plus one standard deviation away from the mean. And this line here would be the average minus one standard deviation away from the mean. And then if we wanted to go 2 standard deviations away from the mean, it'd be like the average plus 2 standard deviations away, the average minus 2 standard deviations away. And we can see that. And one of the rules that we need to memorize, and I don't memorize many things, but this is one that we need to memorize, is, here we go, 68% of the data, no matter how wide or how narrow your standard deviation your normal distribution is, 68% of the data lies within 1 standard deviation away from the mean. And that means 1 down, like 1 less, and then 1 above. 95% of your data, or of the people, whatever you're testing, is within 2 standard deviations away from the mean, and 99.7% of the data is within 3 standard deviations away from the mean. Okay. The wider your normal distribution or your bell curve is, this means that the data is less clustered around the mean. So the less the data is clustered about the mean. Okay, but if we're taking a look at a more narrow and a taller and skinnier, basically, bell shape, then that means more data is clustered about the mean. Okay? And then this is just what I was saying, just in written form. So 68% of the data will lie within 1 standard deviation away from the mean, 95, and then 99.7. Okay, so let's actually take a look at this one. So let's do predictions from the normal model. Okay, so Henry is 168 centimeters tall. In his high school, boys' heights are normally distributed. So as soon as they're normally distributed, I always draw a curve. I mean, sometimes you don't have to, but they're normally distributed with the mean, so the average here, of 174. So let's put 174 right in the middle. We know that's the mean. We also know that it's the mode. The mode we don't need it in this one so far, but we can always just keep that in mind. and a standard deviation of 6 centimeters. So what is the probability that the first boy Henry meets at school tomorrow will be taller than he is? Okay, so let's take a look at the standard deviations. And I'm going to actually draw this way bigger. I'll do all the work. Okay. So down the middle is 174. Now, if you're 1 standard deviation away from the mean, what this means is, so 174 minus 6. And I'll show my work just so that we have an example. So let's go 174 minus 6. So this number right here is going to be 168. And that's Henry. So let's put an H there. And that's 1 standard deviation away from the mean going down. And then if we do 174 plus 6, because the standard deviation is 6, we get 180, correct? Now, I don't know where those are coming from. Okay, so we get 180. Here we go. Now, if we refer back to the previous screen, so we know right now that Henry is 1 standard deviation less than the mean. So if we come back here, what we want to look at is 1 standard deviation away from the mean is 68%. So what that means is 34% of the individuals are negative 1 standard deviation away from the mean to the mean, and then the other 34% are from the mean to plus 1 standard deviation away. So let's calculate that. Okay, so we know from here to here is 34%. Okay, and we always know that right in the middle, this one stands for 50%. So let's do the 50% minus the 34. And what does that equal? %. Okay, so from the start of the tail all the way up until 1 standard deviation away from the mean, this accounts for 16% of the data. Okay, what does that mean? That means that 100 minus 16%. When we do that, we get 84%. So therefore, 84%, there is the probability that 84%, there's an 84% probability that when Henry meets a boy at school tomorrow, he will be taller than Henry is.